This is IQE8, the calculation question. The question states, every winter break, I take a plane to Oman to visit my family. Combustion gases enter the converging-diverging nozzle in the plane's engine at 5,500 kPa, 2,500 degrees Celsius with negligible velocity, and a Mach number of 2.5. Find the exit temperature, pressure, and velocity. So, we assume that combustion gases are CO2 because we do not have we do not have the properties of combustion gases in handout 8A. And we know that combustion gases are mostly CO2, so we'll assume combustion gases are CO2. And we assume ideal gas, one directional flow, constant Cp, isentropic, and steady state. Known is our stagnation temperature, stagnation pressure, and inlet velocity, stagnation velocity, be negligible, so 0, and the Mach number of 2.5. So our properties, which is just the properties of carbon dioxide from table A1 in handout 8A, is for the ratio of heat capacities is 1.288, the Cp is 0.804, and R hat is 0.1889. We're finding exiting temperature, pressure, and velocity. So, first, to find the exiting temperature, we use the equation to solve for it in the back of handout AA. And we plug in, first of all, we rearrange to solve for exiting temperature. We plug in our values, which is the Mach number, the ratio of heat capacities, and the stagnation temperature to solve for the exiting temperature, and we get 1,460. Now we use this equation to find the exiting pressure. After plugging in all of our values, we get an exiting pressure of 312 kPas, and we know that to solve for velocity, we need the Mach number and c. We know that this is the equation for c is equals to root kRt. We plug in all of our numbers from our knowns, as well as t exiting that we had just calculated, and we convert to meters per second squared using this conversion factor, and we get a c of 596. We plug that into our equation, and we get a velocity of 1,490. This is a high velocity, makes sense since it is an airplane. The theoretical part of the question says, why is it important that the plane has a converging diverging nozzle? Well, it's important that the plane has a converging diverging nozzle because a converging nozzle allows for the Mach number to exceed 1 and the flow to be supersonic. And the momentum values, the convection out terms of mass and velocity increase, and the pressure increases, which creates a large thrust forward, thus increasing the speed of the plane.